Hello, everyone. My name is Eric. I went to the University of Illinois Chicago and studied electrical engineering. And right now, I work as an electrical instrumentation and controls engineer based in Chicago as well. So, a lot of these videos will be tailored primarily to students who are studying for their fundamentals of engineering exam, but this is also great videos for refreshers for students that are maybe in the summer or students that are going back into college and they need a refresher on a lot of these topics because these are pretty crucial topics that are pretty fundamental for most engineers to know which in today's case would be mathematics, and more specifically, we'll be going over derivatives and common derivatives, and we'll also be going over the product rule and the chain rule as well. So let's get started. Some of the most common derivatives you'll see are constants. So if let's say you get a derivative of what is derivative 1, that becomes 0. If let's say you have another common derivative you see is the power rule. So let's say I have x squared. What you would use is you do, in this case, x2 minus 1, bring down the 2. So then in this case, the derivative of x squared is 2x. Another common derivative you'll be seeing is the exponential. So if let's say you have the derivative of e to the x, that stays the same, e to the x. However, if let's say you have e to the 5x, you actually bring down the 5 and it becomes 5e to the 5x. In this case, because the numerator, the the number in front is 1, so that's why it stays the same. Another common derivative you'll see is natural log. So the natural log of x is 1 over x. And then some other common trig derivatives you should know is the derivative of uh, sine of x is cosine, and the derivative of cosine is negative sine. So those two at the bottom. Now, another thing that's going to be pretty crucial is knowing the product rule. So we'll be going over some problems and doing them together. So essentially what the product rule is doing is if you have, let's say you have two uh, functions are two separate identities that are being multiplied by each other, there's a common product rule, which is you do u to the v prime plus v to the u prime. So I have an example on the board we're going to do. So we're going to do, if let's say I have x cubed multiplied by x squared plus 5. If I took this function over here, I would do keep the x cubed. Then I would take the derivative of this, which in this case would be 2x. Then I close the parentheses because the derivative of 5 would just be 0 based on the constant derivative rule. And then the next one you do is you add them, and then you take the derivative of u, which we would use the power rule for. So then we get 3x squared. And then we multiply that by the v function, which stays the same in this case. Now, so from here, we can just multiply the two. So in this case, we get 2x to the fourth plus 3x to the fourth multiplied by 5 plus 15x squared. And if we take the derivative of this, we get 2x. Oh, sorry. You would add these two, so you get 5x to the fourth plus 15x squared. And then that's the derivative of this function, which gives you this. So I erase the board. We're going to go through some more product rule problems and then go to a chain rule problem as well. So for this one, if I have x cubed multiplied by the exponential of e to the 5x, then first if I call this u and I call this v, going back to that formula we were looking at earlier, then I would keep my u, which would be x cubed, multiply it by the derivative of this, which would be my 5e to the 5x, and then I add it, and then I keep my u, I take the derivative of u in this case, which would be 3x squared, and then multiply it by e to the 5x. So that stays. So this is my solution for this problem. We can keep it as is. Next one we're going to do is this one. This one will be a little bit different because now we have a trig function involved, but same process. So this is called as u, let's call this v. So I keep my u, which is x squared, multiplied by the derivative of sine of x. If you remember sine of x, the derivative of that is cosine of x. And then I add it, and now I take the derivative of the u, which gives me 2x, multiplied by sine of x. So that stays the same. That's my solution for that one. Now this one's going to be a little bit different. We're going to be doing a chain rule problem. So essentially if I drew up a problem, so let's say I call 5x plus 1 and it's to the fourth power. So now we have a function within another function. And what the chain rule states is that I take the derivative of the outside first, and then I multiply it on the whatever's inside. So let's say my 5x plus 1 to the fourth. So we want to take the derivative of what's outside first. So let's just call this u and keep it easy for everybody. And let's say u to the 4 is what's outside. Now I take the derivative of this. So if you guys remember 4 minus 1, drop the 4. So then I get 4u to the third. So that's my function on the outside. Then I want to keep this u function on the inside. So then I get 4, 5x plus 1 to the third. And then the last thing is now you take the derivative of what's inside. So in this case, 1 would be 0, and then 5x would be 5. So then we multiply this by 5, which would then give me 25x plus 1 cubed. So that's my solution for this one. So I have two more problems for us to work out, a bit more challenging, but it's definitely an accumulation of everything we've learned so far. So let's get started. So for this one, the first thing we want to do is take the derivative of what's outside first. So in this case is sine. So the derivative of sine is cosine. So I go over here, I put cosine of what's inside here, which is x squared plus 1 cubed. Then what I want to do next is I want to take the chain rule of what's inside here, right? So the chain rule, let's call this u, for example. So u to the third, the derivative of u to the third is 3u squared. Then I want to plug my u into here, so then I get 3x squared plus 1 squared. And then I want to multiply this by what's inside and the derivative of what's inside here, which will give me 2x. So to make this look nice, essentially this is 6x x squared plus 1 squared. Then I want to do is multiply this by this, which gives me cosine of x squared plus 1 cubed multiplied by 6x x squared plus 1 squared. So that's my derivative for this one. And then for the last one, it looks a little bit more intimidating because now we have a natural log. But if you remember the natural log of x, the derivative of this is 1 over x. So in this case, what we do is we take the derivative of what's outside first. So we do 1 over x squared plus 5, right, using this. And then we multiply it by what's inside, which in this case would be the derivative of x squared plus 5, which is just 2x, which gives us 2x over x squared plus 5. So that's my derivative.